Okay, so please turn to page 21 for instance drill number 9. Okay, let's take a look at the question together. Suppose y is a subject, varies jointly as x squared, the first unknown, and z, the second unknown. So when x, a, z, y will be this value. Express y in terms of x and z, and then find the value of y. And when x equals 2 and z equals 5. So we can see that actually this is exactly the same type of questions in direct variation or in inverse variation. We've done this 1,000 times, so many times. So the only things changed is now we are doing joint variation now. Okay, so let's try together. Part A, because y varies. Okay, join C as x squared. So you may wonder now, y varies join C as x squared, and is that it does not mention about whether it is direct or inverse. Okay, so mark it down, please. If no mentioning direct or inverse, that means it is direct. Okay, actually it is preset to be direct if I did not mention that it is inverse. Okay, so if you want to specify, if you want to clarify that it is an inverse variation, you have to put it down. You have to write down varies inversely. Okay, so if you do not mention or if you do not clarify whether it is a direct variation or inverse variation, I will always take it to be direct variation. Okay, so in this case we take this as direct variations. So here y varies directly as x squared and z. Okay, so do not add any notation here. There will only be multiplication and division. Okay, no addition and subtraction. Always connect the unknowns by multiplication or division. Okay, so y varies jointly as x squared and z. So the multiplication sign indicates joints, the variation, the relationship joints. Okay, so varies directly as x squared times z. Therefore, y equals to kx squared z. There will only be one variation constant, where this k is not 0. Because x equals to 3, z equals to 7, y is 126. Therefore, 126 equals to k times 3 squared times 7. Okay? So we have 63k equal to 126 and k equals to 2. Okay? Therefore, obviously, the final answer will be y equals to 2x squared z. That's all. Part B, find the value of y when x equals to 2 and z equals to 5. Okay, from last part, we have 2x squared z. Since x equals to 2, z equals to 5. Therefore, y equals to 2 times 2 squared times 5. Okay, so we have x times 5. That means 40. Y equals to 40. Isn't it simple? Okay, so remember when we are doing joint variation. Okay, all the expression will be linked together by multiplication or division. If they vary directly, then multiply them together. If they vary inversely, then put the one that is inverse to the denominator. And that's as simple as you see here. Okay, let's do one more instant drill. Instant drill 10, page 22 here. Okay, let's take a look together. It is given that p varies directly as q and inversely as square root r this time. Okay, so all we need to do is simply put it down. P being the subject, varies directly as q, so q on the numerator. Inversely and square root r, so root r should be in the denominator. Therefore, p equals to kq over root r, where this k is not 0. Okay, note that there will only be one variation constant in the expression. Then substitute all the value in it. Therefore, 49 equals to k times 4. A lot of you forgot to put bracket in this line. Over, oh, not 4, sorry. It should be, the value of q is also 49 over roots 4. Over roots 4. Am I right? Yes. So therefore, the next step will be 49 equals to k times 49 over 2. Therefore, obviously, k should be 2. And hence, p is actually 2q over roots r. So for part A, for part B, all the thing will be the same. Since q equals to 24 and r equals 16, therefore p will be 2 times 24 divided by root 16, which is 2 times 24 divided by 4, so 12. Okay, so you can see actually, although it is a new type of variation, joint variation, but all those things you have to do are actually the same with what you have learned in direct variation and inverse variation. Okay, so let's continue tomorrow. Okay, but before I end this video, I would like you to do just one question to prove that you have watched this video. Okay, very simple question. You will finish it within 1 or 2 minutes, believe me. Okay, so please go to exercise 6C, question number 1. Question number 1, which is on page 23. Okay, finish this and let's take a look at it tomorrow, and that will show that will prove to me that you have watched this video. Okay, very good. See you tomorrow.